Okay, welcome back, everyone. We are continuing now, and let's jump back to some more AI stuff. Our next speaker is Saloni Garg. Saloni is International Woman in Open Source Award winner. So we have a winner here. A Google Venkat Scholar, a comp science undergrad, and Mozilla Open leader. Saloni worked on several AI projects that are based on Generative Adversarial Networks and has created pictures of dogs, people, spaces, wrote music lyrics, and created paintings. And all of those have the same thing in common: they did not exist. So Saloni is hearing going to entertain us a bit as well, and we will get to play some kind of game. So without further ado, here is Can You Guess Which Song Snippets Are Written by AI? Stage is yours.
Thank you. Hello, everyone. Thank you so much for coming to listen to me. So let's start. This session is going to be actually a little bit interactive, so please participate. Please scan this QR code, and then we can start. So as the title suggests, can you guess which songs are written by AI? So let me give you a brief introduction about what GANs are. GANs are basically Generative Adversarial Networks. So Generative Adversarial Networks, one of the very good applications of them are to create things that do not exist. And by saying that creating things that do not exist, I mean anything. It can be a cat, a dog, a face, a painting, a song, anything you can think of, like a cityscape, and we'll see some examples, see some interesting examples in this presentation. So let's go. I think everyone has scanned. This is just out of my own curiosity. Can you please quickly write which country you're from? I'm sorry for giving such a short timer on this one. Oops, it ran out already. Okay, most of the people are from Lithuania, or at least I can say Lithuanian people were the fastest to type. So, okay. Now, this is a short quiz. So you'll have to guess which lyrics are actually written by the AI. And we'll start with a very easy question. This is, I mean, it's not a long quiz and you're not being marked or rated or something, and no prizes or anything. It's just for fun. And there are just two questions, actually. Let me actually tell you. Okay, question 1 of fun. Which lyrics are real? So there are two options. Get ready. First one is love some. No, I'll not read it, actually. You get to decide because the time is short. Love someone, always love, hallway, the breakdown. And the second one is I'm in love with the shape of you. We push and pull like a magnet too. So I'm not sure if everyone is going to get it right. Which one is real? Which one is written by AI? Both? Okay. That was a good one. Time's up. Oh, there are some people who answered the other one. Wow. Okay. Okay. So the next one is actually going to be interesting, and you will have to put a little bit of thought in it, and then we'll discuss this after. Then there's a question next, and then we'll look at what GANs are and how they work. I mean, how machine learning networks work in general, and then we'll discuss that again on how you could have easily identified the answer. So this one is a little serious one. Question is still running. These are the two lyrics. Let's read them one by one. So first one is, yes, I know it's not perfect. Yes, I know it's dreaming. So when I have nothing to say and no one else, I will softly whisper. And the second one is, you fall asleep and I put a spell on you. And when you wake up, I'll be the first thing that you see and you'll realize that you love me. Now you decide which one of these is real and just vote. Okay. At least it's not like 101. 100 and 0, I'm sorry. All right, so most people think that this one is real, and we'll discuss this later, if which one is real actually. Let's now see what are GANs. What is a generative adversarial network? So GANs were first created by Ian Goodfellow, who is a Google data scientist, and he created them in order to he did not create them to create new images of people that do not exist. The use case was entirely different, but this is what we have applied this to because it's an interesting one. So it is basically a machine learning model, a machine learning framework in which two neural network models actually compete with each other in a zero-sum game. When I say zero-sum game, it's basically that two neural networks are actually competing against each other, and there is no way that both of them can win or both of them can optimize their loss functions. Let's actually understand that with the diagram. This is a simple analogy that will help us understand this better. So basically, there are two neural networks, generator and discriminator. And now we can think of it like this. So generator, the task of generator is to create money or currency notes that actually look like real money. So, I mean, think of it as a counterfeiter whose purpose is to print fake notes. And then there's bank who is actually printing real money. Now the job of the discriminator or the police is to actually identify and classify which one of these is real money and which one of these is fake money. Now you might think that it is an easy job and there are a lot of things, there are a lot of technologies that police have to actually identify this, which is true in case of currency notes probably today, but we will understand this in other aspects. For example, identifying which images of people are computer generated and which people actually exist. So this is just to give you a basic idea of what generator and discriminator are. In real GANs, these two are the neural networks, and we will spend a lot of time talking about generators and discriminators in further slides. Now that we have that information about that analogy, we can also think about this analogy that so basically there is real data. There is a data set, huge data set, which consists of real world images of people that actually exist. And there is a generator which is forging the images and which is basically trying to create fake images. And then there's detective who is trying to classify. This is again the same thing, it's just in context of images of people. So it's more relatable to our actual example. Now, in terms of neural network language, so this is how a very basic vanilla vanilla generative adversarial network look like. So there is a noise source. What is noise source? It's basically input noise source. Basically, it's a huge data set of real world images. So generator takes as input a noise source, a huge data set of pictures, and then it tries to create images that look real. So it creates fake data. We'll mark that as x dash, and the real data, which is x. And it is basically going to the discriminator. Now, as we discussed, that the job of discriminator is to be able to classify between the two. And then this thing we have not discussed yet. We'll discuss what backpropagation is. Backpropagation is one of the very good additions to GAN, which actually makes GAN what it is, actually makes the process of creating real-world images, AI-generated images look more real-like, if that makes sense. So once the discriminator has classified the two images as real or fake, for example, in our particular use case, the discriminator defined an image as AI generated. So basically, it gave false input, and that data will go as backpropagation again to the generator and to discriminator both. And why we will give this data to the generator is because so generator created that image, and it came as an input, as a feedback to the generator, that this data was classified by discriminator as fake. So you have failed in making the discriminator believe that this is a real world image. Now generator will take this into account, and this will actually be used in the training of generator neural network as a negative data set, as a negative data instance basically. This cycle will go on and on until the generator is able to create an actual image which discriminator will pass off as a true image. Now, what is the task of discriminator? We discussed a lot about what generator does, but what is the task of discriminator? It's only classifying whether an image is real or fake. And discriminators can also fail. So basically, the actual goal of generator is to be able to pass the check that discriminator has put in place and to be able to get its image classified as real. That is what discriminator is trying to do. So it is basically trying to classify the data instances in two categories, AI generated or real or fake, basically. Now, what are the loss functions? So in any machine learning model, loss functions are basically the functions where we are trying to you can think of loss functions as a cost associated with every neural network. So for example, with generator, there is a specific cost, there is a specific loss, and while trying to make the neural network outputs better in general, we are trying to optimize the loss function. We're trying to reduce the cost as much as possible. So this is again the same thing, just in a different diagram. There's a random image in generator, and there's a real image as a sample, and goes to discriminator. And basically, the new thing here is we have two losses: generator loss and discriminator loss. Discriminator loss, what is discriminator loss? It is basically penalizing the discriminator for letting the letting the generator generated images get passed as a true real world image. So basically, it's penalizing it, and that is how the loss is getting back propagated, and that is how discriminator network is getting better over time. This actually helps it get better over time. Okay, back to our question. So which person out of these two exists in real world is your question. I think that was too much theory and we needed this poll. Okay, so most of the people think that person is real, but let me tell you, this person is real and that person is AI generated. And how can we actually identify that? So there is no short way to identify which person is real and which one is fake. But for example, in this one, we can see that this girl is posing, and posing is something that AI is not very good at, because you know what we feed as a data set to the model are actual faces of people. We don't feed as raw images, we don't feed like poses and portraits and stuff. So that could be a very good way to check which image is AI generated. Like these hands and everything is falling into place, but in that person's background, nothing is clear. So we can identify that as a fake one. But nice, I succeeded in getting votes on the wrong one. Okay, back to theory. So a little bit of it. This is actually the mathematical representation of GAN. This is how GAN's equation would look like. So here dx is basically the function of discriminator, and gx is basically the function of generator. And as I told in the very first slide, that they both are actually in a zero-sum game, which means only one of them can win. I mean, if one of them is winning, the other one has to lose. So basically, they are not proportional to each other. They are counter-proportional to each other. And we don't have to actually go through the entire theory and how the log functions would work. This is a binary classification problem with sigmoid function for the discriminator. What is binary classification problem? It's basically the output of discriminator will be either 0 or 1. The image is real or fake. There is no logistic regression or other, I mean, there's no labeling of data that is, there's no logistic regression of data that is happening here. Yep, so that is the mathematical representation of GANs, and we can actually look at from here. So Z is the latent space, the noisy input that we will feed into generator, same as what we discussed in a simpler looking model. This is the real world data set, which is true and labeled. Then it goes to generator, and then GZ, which is function of generator. These are the generated samples by the generator. And then X are the real samples which are coming directly from the noisy source input. And then we have the discriminator, which is doing its job. And this is the back propagation. Let's not go to back propagation yet. Let's first see what discriminator is doing. Discriminator is basically d of x, the discriminator function, labeling it as real or fake. And then whatever it has labeled, that data is going as a back propagation to both of these, discriminator and generator there. So what is going to generator is 1 minus d of g of z, which is, first there was a g of z. G of z is basically what generator created. And then d of g of z is basically what discriminator decided on what generator created. So that is that. Yep. Okay. Now again a question, which person exists in real world? I hope you get this right this time, although it's very hard. Okay, not bad. So this person actually exists in real life, and that was right. You guys were right. And there is actually no way to check this or validate this, but one good thing that you can probably think of is that this guy is wearing glasses, and this also has a pimple in the right place. So if you would have generated a pimple with an AI, it might have been like on his glasses or something, because AI does not is not fed with pimple data. So other thing is that his glasses are properly symmetrical, which is often a mistake that AI can do if there is no glass. I mean, there is no data, enough data for people who are wearing glasses. So like this frame can be square and this can be round or something. So this can be very weird also. However, AI did very good in this one because this person looks very real too. So now, just a quick overview on how we can generally catch the glitches that AI makes. So one of the very good thing is the background. This is an image created by AI, and the background, as you can see, the background is not very good. I mean, it's very evident that this image is fake, and why this happens is because the focus is on the face, as I just said, and it is not focusing on background, and backgrounds are just selected randomly. So I don't know what this selected, some hands and something. Yeah. And then again, the same thing. So AI generated background. I don't know. It was trying to create some person's eyes or something, but this is what it came to. So this is pretty evident too. But these kind of glitches we can easily avoid by making our model to only select solid color backgrounds. If you are on the other side, not on the detector side, but if you are on the generator side, and if you want to create images that actually look like real, so you can just decide to choose a solid background, or you can just get a data set of backgrounds that it will use randomly to avoid these kind of things. The other one is accessories, as I talked about glasses and also pimples and also this mic. So it is starting from nowhere, just so this can also be one of the catches or glitches. And the last thing is symmetry. So so you see, sometimes AI can create like and one eye color is blue and the other one is yellow, and then it would not match. And then teeth are a very good point of catching the glitches too, because teeth generally in the images that we feed, teeth are not very visible, and AI does not have enough data to train on how the teeth would look like. So they can be unsymmetrical, or they can be very weird looking, they can be warped or something, and it is a good way to catch machine learning generated images. And this is, yeah, I mean, this accessory doesn't actually look very weird, but if I remove this circle, I actually put this circle in wrong place. It is actually starting from nowhere. It's not starting from the ear. It's just hanging somewhere in the air. Okay, yes? No, we can, yeah, okay. So we can actually do that, but the only thing is that such people, the number of such people is very less, so there is not enough representation in the raw data. So AI is not trained on that data. But if we know that our sample size of people who are handicapped or people who are uh, queer, or I mean who look different than the normal population, we can train data set on that and it'll be able to identify. It's That's right. It's difficult one. I mean, the only thing you could have said is that this earring is hanging in the air, and this is the. I mean, we are not highlighting that why is this a lady and has beard or something something. That's not even a question because that's possible in real world as well. We are just talking about these things, and the teeth. Teeth are actually really. Unnatural looking in some images. I don't have the data set, but I will probably send it to you if you want. Yeah, and there is one good resource if you are interested in learning more about this. There is this website called thispersondoesnotexist.com. I'm sure many of you would have heard about it. Yeah, and this is really cool. And there are websites like thiscatdoesnotexist.com, thisfooddoesnotexist.com, and we'll just take a brief look at them also. Okay, yeah, back to our lyrics. So this is the lyrics that we saw in the first few slides. So I don't actually remember which one you said as fake, but I think this is the one that was identified as real by most people. So that is correct, that this one is the one that is actually real. Why and how you can actually identify that is, so there are basically two things in writing information, like written information. One is grammar and the other one is context. And grammar is actually syntactical, grammar is calculative, and people can easily, there are tools like Grammarly and stuff that can check grammar, and grammar is no longer a problem for AI to be correct in. But context is one big problem. So if you see here, you fall asleep and I put a spell on you, and when you wake up, you will be I'll be the first thing you see, and you'll realize that you love me. So you see how this thing is very weird, but this somehow makes sense. This makes sense. I'm not denying that it's not weird, but the sentence has a meaning. On the first one, it says, "Yes, I know. Yes, I know it's not perfect. Yes, I know it's dreaming." Like, what does that even mean? In the first few sentences, you'll know. And then, so when I have nothing to say and no one else, I will softly whisper. That just makes no sense. And context is one of the things that will help you identify which one is fake and real. That's true. Yeah, that's true. I mean, okay. And since you're talking about context, one of the very popular things that AI fails at is writing jokes. So something, and that's hilarious. So this is actually the joke written by a real person, not AI. But let's see at a joke written by AI. Olive Garden commercial. Int Olive Garden restaurant. A group of friends laughs at a dinner table. A waiter. Oh, I'm sorry. Why is this screenshot? Okay, I don't think so. We'll be able to fix it now. But a waitress to deliver what could be considered food. Pasta nachos for you. We see the pasta nachos. They are warm and defeated. And I think only AI would laugh at warm and defeated stuff. So this is a big problem of context, and there are a lot of research papers and stuff written on how to, actually be humorous, and a lot of research is going on that. And this is a really interesting area if you are looking to, jump into writing code in AI. And then, as I talked, weird stuff that exists. This cat does not exist. I mean, you can never in a million years tell that if this cat exists or it does not exist, because there are like no short ways to catch it. And then this vessel does not exist. But I can say that this vessel does exist because some artist might have created this vessel. However, this vessel did not exist in the data set that was fed to AI. So this is how it works. And then there is this website called This Word Does Not Exist. So it is trying to imitate the dictionary. I mean, the layout of that dictionary follows. So me sit right, a mite which frequently exudes yellowish brown matter in arthropods. Like, all these words are really weird, and these don't exist. But if you were to show it to someone and were like, "Oh, I'm doing a research study on mesorites," and they would be really interested and they'd be impressed. And then this cityscape does not exist. This is also. So basically the point is that you can feed any data into GANs and come up with outputs of the things that do not exist. You just need to have the data in the first place, the raw data in the first place. Now, lastly, just to recap what we went through. So random input goes to generator. This is how it works, basically. So the only thing that you need to have if you were to create your own GAN was the random input. This is a big thing. And without a good amount of random input, you'll not be able to get good discriminator results. So you enter a random input, there's a generator which will create some AI generated image, but trying to make it look real life-like. And then there is an actual real image which goes to discriminator, and it classifies as real or fake, and then it propagates back, and the cycle goes on, and there are you can run it for as many number of iterations as you want until you get the desired amount of accuracy in your final images. So if you just see, generator is the thing that we are trying to optimize. Discriminator is just one of the tools that is used to optimize generator. The actual data that will come from generator is what we are looking at as the output. If you're interested in code, I would be very interested to look at the code with you backstage and discuss this if you would like. So this is one of the very good GAN repositories. I'm not sure how, if you have read about Colab. So basically it's Google's version of Jupyter Notebook, and there is the entire code of GAN written here, so you can go there. Thank you, and let's connect, and let's talk about GANs.
Thank you, Saloni. Do we have any questions? We do. There we go.
How big data sets do you need for training these things?
That actually depends on how much accuracy you want in your final images.
95%, let's say.
No, like not
like I want to check 95% of auditorium here.
Oh, okay, like that. Well, that would require TBs of data for sure, and like hours of training on Google Colab. So, I mean, I can't say like 5 TB of images, but like require huge data for 95% of people here to recognize this as true. Yeah.
Thank you.
But if you were to just do a home project, like just to do a side project, I don't think you'll reach that accuracy on your machine without using some cloud networks. But this is definitely worth doing. I mean, you can start off with something that is more easy to deceive, for example, cat or dog, right? Rather than creating the actual people's face images. So yeah, that would actually be a nice weekend project.
Amazing topic, thank you. Question: what happens if discriminator misclassifies the generator's image? Like if it's supposed to be fake, but it thinks it's true, and
so yeah, let me go back to this slide, the loss function one. So if a discriminator has misclassified an image that was generated by generator, but discriminator let it pass, then it is actually a success for our model in general because our discriminator had let it pass. But so basically there are two types of learning: supervised learning and unsupervised learning. And while the training of discriminator itself, we will back propagate that data, the discriminator loss, into discriminator to make discriminator better, to make it better suited to be able to identify images as fake or real. So this back propagation is what we're talking about here. Discriminator loss goes to discriminator. And this we can run for multiple iterations until we get it right.
Any more? We do have some time.
Thank you. I wanted to ask if you know about the state of guns being used in video, and are you scared that maybe when it comes to the topic of deepfakes, guns could be used to manipulate our perception of reality, so to say?
Actually, this is a really interesting topic, and I would have included some deepfake videos if I knew that I would be left with some time, because deepfakes have really cool use cases. I don't know which place is it, I think Korea or something. They actually made a deepfake of a president or prime minister, and that was entirely a deepfake. I mean, the prime minister didn't give that speech at all, and people actually believed it. And there are a lot of deepfakes by Elon Musk all over the internet. So I really think that this is an interesting use case, at least of now. In future, I think it will just be some, like, just another AI thing. People can use it for good and bad, and there'll be laws in place. But I don't really think that this is a threat or something, at least as of now, because it is kind of clearly identifiable. And to be able to create your deepfake, I cannot just take random images of yours from your Instagram and just create your deepfake. I mean, that would be really fake looking. I need to have a very deep scan of your face, how you open mouth, how you do stuff, how your expressions are, and yeah, like that. So at least as of now, it's just a fun project.
Thank you. So you already touched the topic about how discriminator could be used in real life, like what problems it can be used to solve, right? Are there any real, I don't know, tasks, problems that generator can be used in, like, not only for teaching the discriminator, but what use cases can it be used for?
Yeah, actually, I said the opposite. The generator outputs are what we are looking as the output for this thing, and discriminator is only used to train generator. But I think you mean to ask what are the real world implications that discriminator could have, right? Because discriminator is actually just classifying real or fake, and the data that is coming from real or fake is actually going to discriminator as an input, and that is being used to better the generator in the end.
That answers your question? Okay.
Yeah.
Does that require a deeper conversation after the presentation? Okay. Do we have any more questions there?
There's a lot of research going on, let's say, in generate the different images. But is there also a lot of research going on in recognizing it?
Sorry, can you repeat that? There's a lot of...
Is there also a lot of research going on in recognizing, let's say, generated stuff? So you can generate...
Oh yes, that's exactly what discriminator does. So it actually recognizes the generated stuff and tries to make better, classifications on real or fake. So yes, there is research going on GAN in general, which includes both the discriminator and generator parts. So trying to better both the classification process and also the image generation process.
So you could use a discriminator, let's say, as a separate piece to identify if an image was generated, yes or no.
Yes, yes,
okay.
yes, of course, yes.
I had the idea that they needed to be used in
the only way why this is in this loop is because this is trying to make the generator better in the end, because that is what we are optimizing for. But you can, of course, use discriminator as an isolated piece to do classification.
Next question. Okay, everybody knows everything now. Okay, brilliant. Well, thanks again. One more time, round of applause.
Thank you.
Do we have a gift for Saloni? Yay. Okay. We are going to have a bit of a longer break. I think we're coming back 5 to 4. Yes, 5 minutes to 4. So let's get some air and coffee.